Hi everyone, this is Miss Graham and I will be going through section 4.2 with you today, looking at angles and angle bisectors. This lesson builds off of our last lesson of 4.1, looking at segments and angle measures. Let's go ahead and start with our learning targets. Today we're going to apply the angle addition postulate to find angle measures. We're also going to use the definition of angle bisector to find angle measures. In the past few years, you may have used a protractor before. This is a math tool that helps you measure different angles. The number of degrees in an angle is called its measure. Below, for question number 1, we're going to determine the measure of each angle using the protractor above. The first one is done for you. If we look at the measure of angle AOB, we are looking at AOB, like I have highlighted right there. And we can see that we are going to be starting off at a point on the ray AO. It's going to be at 0 degrees right there. And what we want to do is we want to measure up to figure out how big that angle is. For this type of measure, we're going to be looking at the numbers at the bottom. So we can see here that it is 50 degrees. Let's go ahead and try our next one together. So we're going to look at the measure of angle BOC. So I'm going to go ahead and highlight that so you can see which one angle we're looking at. And we want to go ahead and look at this and see, wait a minute, we're not starting at 0 degrees. What we're trying to do is measure this angle right here. What we could do, just like what we learned in 4.1, was to find the distance between 2 points. We could subtract the coordinates of those and take the absolute value. We're essentially doing the same thing here with an angle. We're looking at where it starts off at 50 degrees and it goes to 90 degrees. So this is the type of math that you are working with and thinking about. You're thinking about the absolute value of 90 minus 50, or you could think about 50 minus 90. That's fine. Either way is going to work. But we're going to see we're going to get 40 degrees for that. Now, again, some of you might think, okay, I can just count up how many degrees from 50 to 90. That's fine as well. But this is another approach, bringing in what we learned from our last lesson. I'm going to go ahead and do one more problem with you. So let's look at the measure of angle AOC. AOC, I'm now going to highlight it. So you could probably see that we are combining the last two angle measures that we went with. We're seeing them all together. We're combining 50 degrees with 40 degrees. Easily we can see that's 90 degrees, as well as that does make a right angle right here. So we know together it creates 90 degrees. I'm going to give you an opportunity right now to go ahead and try parts D, E, and F. Go ahead and find the angle measures of those. Alrighty, I was able to do my work and I have a little color coordinating, and you can see that the measure of angle EOD was 30 degrees, measure of angle BOD was 100 degrees, and the measure of angle BOE was 130 degrees. I applied what I learned before, and I showed a little bit of work at the top to show that I'm looking for that measurement. Now, just something else to keep in mind is that you definitely want to make sure that when we're looking at angle measurements, you want to start off right here and work your way up towards that way. I know the protractor does have angle measures at the top that says we could start here, but just for good mathematical procedure, I definitely want to make sure that you are starting off right over here when you're measuring angles. Looking in the right margin, we can see that we have a protractor postulate, something to keep in mind. It says, to each angle, there corresponds a unique real number between 0 and 180 degrees, called the measure of the angle. The measure of the angle formed by a pair of rays is the absolute value of the difference of their associated numbers. That's exactly what we just went through. Now, let's look at number 2. It says to use a protractor to determine the measure of each angle. Now, fortunately, because I am using this on the iPad, I can reference the protractor I have above and measure each of these angles. If we were in the classroom, we would be able to do this by hand with a protractor, but it's also good to visually see and practice this as well digitally. What I'm going to do for each of these angles, such as for angle TQP, is I am going to outline it and highlight it and then bring it on up to the protractor to see what its measure of its degrees are. So let's look at angle TQP. So TQP. And then if I was able to pull that, I can see that I could pull up the measure and I could extend the lines and see where it lines up to. I can see that it starts off at 30 degrees and it goes all the way to 140. So what I would do is I would do my 140 degrees minus 30. Again, you could do the absolute value bars. And you could also do 30 minus 140 degrees. Either way, you're going to get 110 degrees. Now, it would be a lot easier to do this if we did have a protractor and could hold it up and measure it. A lot of the times, if we are bringing this all the way up and measuring it, I know I have some of the work that goes with it, but you can see we can extend the lines. The lines of that gray shaded angle could be extended so we could have a little bit more accurate results. All right, okay, so looking at this, I'm going to have you pause the video right now and I'm going to have you go ahead and measure angle TQR and a measure of angle RQP. All right, hopefully for our first angle measure of TQR, you were able to get around 24. Maybe some of you probably thought 25 degrees. That's okay. The textbook is a little bit specific on that. And for our next answer, we should get around 135 degrees. I know it's a little bit of an estimate, but there's certain ideas that we're looking at here all together. We go ahead and start to look at number 3. It says, using your results from items 1 and 2, describe any patterns you notice. Well, from above, we can kind of see that when we add the measures of 2 smaller angles, we end up getting the angle measure of the bigger angle. Looking at the problem we just had above, right? We got 110 degrees for angle TQP. We have angle TQR, and that was 25 degrees. Together, we found the measure of angle RQP. The whole piece was 25 plus 110. We can see the same thing in number 1 as well. So down here, we're going to say, when you add the measures of the 2 smaller angles, you get the bigger angle. Nice. All right, let's go ahead and look at number 4 now. Number 4 says, given that point D is in the interior of angle ABC, describe how to determine the measure of angle ABC without measuring. If you are given the measurements of angle ABD and angle DBC. So for this problem, I would like to draw a picture to visualize what is really going on. It says we have point D. So I'm going to label it point D. And it's between, on the inside of angle ABC. So I'm going to go ahead, I'm going to create angle ABC. Now remember, when you have your angle, remember that that second letter, the innermost letter, is going to be at the vertex. So that's point B. So it says, describe how to determine the measure of this whole entire angle, angle ABC, if we know, so it says if we know the measures of, this is the fun part. If we know the measures of angle ABD, and we also know DBC. This makes sense now, all right? Looking at this, we know the measure, and let's say, of angle 1 and angle 2. All together, we can find that total angle. So what we would write down is we could say the measure of angle ABD plus the measure of angle DBC, adding those together will equal the measure of angle ABC. So what we just did now is called an angle addition postulate, what it comments on in the margin. All right, this is pretty cool. Let's go ahead and flip to the next page. Let's look at page 46. So we're going to use the angle addition postulate, what we just learned on the previous page, and the given information to complete each statement. It may help to draw pictures to visualize what each problem is saying. So let's look at part A. It says if P is in the interior of angle X, Y, Z. So I'm going to go ahead and draw that just similar to how we did it on our previous page. And I'm going to label X, Y, Z. And I'm going to label my point P on the inside. Then they say, okay, we know it's inside there. Let's say we have the measure of angle X, Y, P. So I'm going to do it in a different color. So we have the measure of angle X, Y, P is 25 degrees. It says the measure of angle P, Y, Z. So the other angle, it says that's 50 degrees. It says what's the measure of the whole angle X, Y, Z? Well, this one's pretty easy because what we're going to do is we're going to do that angle addition postulate, add those two angles together, and voila, we get 75 degrees. Let's go ahead and draw a picture for the next one. So now we have point M. M is in the interior of angle RTD. So I'm going to go ahead, I'm going to draw a sketch. Now remember, when you are drawing sketches of this, keep in mind that they're just a sketch. It helps model and visualize what we're thinking about. It's not necessarily the exact same measures as what we're given. All right, so we say we have point M. Point M is on the interior of that angle. But now here's the tricky part, right? So it says measure of angle RTM. So half of that, again, we know that's 40 degrees. And it says the angle RTD. That's this whole entire piece. Right here, this whole angle is 65 degrees. It wants us to find the measure of angle MTD. So that part we don't know. Well, instead of using angle addition, we're still going to use this theorem in a way, but we're going to do a little bit of subtraction. What we're actually going to do is we're going to subtract out 40 degrees from 65 degrees. Okay, so when we do that, we end up getting 15 degrees. Actually, just kidding on my math, we should end up getting 25 degrees. 25. Teachers make mistakes all the time, and it's fun to always catch them. All right, so we use that angle addition postulate, but we also considered how we could look at it from a subtraction point of view. Part C is going to require you to throw it back to algebra class last year. So I'm going to go ahead and draw my picture in the margin and give myself a little bit of space for this. For part C, we know we have point H is in the interior of angle EFG. So I'm going to go ahead and I'm going to draw angle EFG. EFG. And like I said, we don't always have to do acute angles. We could also do obtuse angles. So you know what? For this one, why don't we go ahead and try an obtuse angle, just to switch it up a little bit. So I'm going to go ahead. I'm going to draw an obtuse angle. Let's try again. We're going to go ahead and plot F as our vertex. We're going to plot points E and G on either of the sides. And we have point H in the middle. We know we're going to be using that to connect. Okay, so we have that. Now it says EFH. So angle EFH is going to be 75 degrees. So I'm going to go ahead and label this 75 degrees. And it says the measure of HFG. Whoa, it's 10x. Interesting. Okay. And then it tells us, oh, the measure of EFG, this whole entire angle here, it says it's 20x minus 5. So we have to think about how we would solve for x, as well as how we could find the measure of angle HFG. So take a second, think about how you would approach this problem. So just like before with our other angle addition postulate, we have to add the two smaller angles to get the bigger angle. And we're going to set up an equation for that. So we're going to do 75 plus 10x equals 20x minus 5. And this throws it back to what we were doing earlier with solving equations, looking at two-column proofs. What we want to do is we want to get all the x's to one side of our equation. So I'm deciding to subtract 10x and move all the x's over to the right side. I then decide to add 5 to both sides. So now I have the numbers on our left side. I'm then dividing by 10 to isolate x. I end up getting x equal to 8. Now keep in mind what that means. We're looking at x equals 8. We didn't find the angle measure just yet. That's what we're going to do with angle HFG, and that's where we will label it with degrees. X just represents what's that unknown number that we're going to plug in to our expression. So looking at angle HFG, HFG is this angle. So I want to plug in 8 right in for here. I want to plug in 8 into that. So we have 10 times 8. That gives us 80. So we have 80 degrees is what we're working with for the measure of angle HFG. Let's go ahead and let's look at part D. Part D says that we have lines DB and EC intersecting at point F, as we can see in the picture. It says if the measure of angle BFC is 44 degrees, and it also tells us that if we know the measure of angle AFB, that's 61 degrees, then we have to figure out the measures of all the other degrees. So I'm going to give you an opportunity right now to go ahead and pause the video, and I want you to try this problem on your own. Let's go ahead and go over our answers. So we can see for the first part, we're going to look at angle AFC. So how much is that all together? Oh, that's easy. That's where we're combining together what we got in the two previous problems. It's going to be 61 plus 44. So when we go ahead and do that math, we should get 105 degrees. Don't forget to label that degrees. All right, let's go ahead and look at the next part. So we want to find the measure of angle AFE. So thinking about this, we already know what this half is over here. And we know that together it creates a straight line. So we know the angle above AFC is 105 degrees. What we're going to do is we're going to subtract that from 180 degrees. So we're going to do 180 minus 105, and that's going to give us our measure for angle AFE, which should be 75 degrees. Last but not least, we have the measure of angle EFD. So EFD, right there, we can see, okay. How do we find that? Well, a similar approach to what we did before is going to yield, okay, we know that this is 75 degrees right up here, 75 degrees. And we can see we're creating another straight line across. Kind of by process of elimination, we know if we take these two, add them together, subtract it from 180, we would get our result. But something else that we're going to preview in the future is something called vertical angles. Vertical angles are two angles that are across from each other, and it's when two lines intersect. We're going to learn that those angle measures are congruent. They are equal to each other. So we know that the measure of angle EFD, even before I do anything at all, will be 44 degrees. Again, we could do the long approach to it, which would be adding 75 plus 61 together. Okay, so what do we get when we do that? We end up with 136 degrees, and then I could do 180 minus 36. That's how I get 44. So that's another way to approach it, but I figured I might as well give you a little bit of a hint at something we're going to get to in the future. Let's keep moving forward. Now let's look at the bisector of an angle. It's a ray that divides the angle into two congruent adjacent angles. Remember, congruent means they're the same measure, adjacent means they're next to each other. So for example, below, if ray BD, as we can see it right here, if it bisects angle ABC, that means these two angles, angle ABD and angle DBC, they're congruent to each other. just like what we have labeled in our picture with the 30 degrees. If we look at the math tip in the margin on the left, we can see that adjacent angles, they're coplanar angles that share a vertex and a side, but no interior points. In the figure, we can see that angle ABD is adjacent to angle DBC. Congruent angles are angles that have the same measure. So we just learned about congruent segments yesterday. Now we're going to be focusing on congruent angles. So to indicate congruence, you can either write the measure of angle ABD is equal to the measure of DBC, or you could say angle ABD is congruent to angle DBC. Either way it works. We're going to get lots of practice at it over the next couple of days. So for our next problem, we are going to go ahead and draw a picture to help us figure it out. So let's go ahead and look at it. 6 says, given that we have, AH is a ray, it bisects angle MAT. So I'm going to go ahead, I'm going to draw my picture like usual. I have MAT, and I know that AH bisects it. That means, remember, these two angles will be congruent to each other. And me showing those kind of curved tick marks, that means those angles are congruent to each other. Just like above when we were working on 5D, where we had the vertical angles, I used that symbol in purple up here to show that those angles are congruent. So knowing this information, so let's see what we have for A. Let's say we know, the whole entire angle. Let's say that whole angle is 70. What would half of it be? Well, half of that would be 35 degrees, right? Because 35 plus 35 equals 70. Now they're saying, let's imagine we have the same picture. Let's say we copy and pasted the same picture, but we're looking at a different part of it. It says, let's say we have HAT. We know that this is 80 degrees. We're trying to look for now the whole piece. Well, keep in mind, both of these are congruent to each other, so we would undouble that. So 2 times 80 is 160. Let's flip to our third page, page 47. You can use definitions, postulates, and properties of algebra to determine the measures of angles. Example 1 has us looking at if QP, ray QP, bisects angle DQL, and the measure of DQP is 5x minus 7, and the measure of angle PQL is 11 plus 2x, we want to determine the measure of angle DQL. So for this, again, I want you to go ahead and draw a picture, see if you can have it set up. I'll give you a few seconds to do that. Hopefully, you can see that we have a picture below that's kind of a nice sketch for us. So if we go ahead and look below, we see they already sketched the picture for us to kind of help us out. Now, they did find the angle measures already, but here's the setup of what we're looking at. We want to figure out the measure of angle DQL, this whole entire piece here from the given small pieces of what we have. So it tells us the measure of angle DQP. It tells us that's 5x minus 7. Then it goes and tells us that we have the measure of PQL, which that's 11 plus 2x. It also uses an important word, bisects. That means these two pieces are equal to each other, which is what they show up above here. It shows us setting them equal to each other and then actually solving for x, because our goal is to find the measure of this whole entire angle. And we need to figure out what x is first. So they do a little bit of math. They show the properties of equality. They end up getting x equals 6. And they use the properties of equality to explain how they got x equal to 6. Right after that, they then substitute 6 in for x into, you honestly could do either expression, DQP, the measure of that angle, or for PQL. We know that it's bisected, so both of these angles will be congruent. Hey, good vocab word. They're going to be congruent to each other. So if we put in, let's say 6 for 5x minus 7, we get 23. We could put in 6 for 11 plus 2x. We get 23 as well. When we add both of those angles together, we get 46 degrees. So it had us make a sketch of it, look at the angle bisector, figure out how to solve for x, figure out how to solve angle measures, a lot compiled together. So this is a really good example to reference. What we're now going to have you do and try on your own is try these A section. I want you to go ahead and try parts A and B, pause the video, and then we'll pick back up and go over each of these. Let's go ahead and check your answer for part A. You should have gotten x is 6. Measure of angle LFM is 70 degrees, and the measure of angle AFM is 140 degrees. Go ahead and check your work with mine right now and pause the video. Checking the next problem, we can see we got x is 9, and the measure of angle LFM is 26 degrees. Go ahead and check your work with mine, keeping in mind that, remember, when we bisect, both of these angles are the same. They're equal to each other. So we know this angle is also 4x minus 10. Instead of having to add those two together, I decided to multiply 4x minus 10 by 2 there. So just another way to approach it. Let's go ahead and look at number 7. It says angle A and angle B are complementary. The measure of angle A is 3x plus 7, and the measure of angle B is 6x plus 11. Determine the measure of each angle. So it gives a little bit of a tip on the right side. It says here in this problem, you know that A and B, those measures of those angles, you know that they're complementary. So their sum has to be 90 degrees. We're going to use that fact to write an equation where we can solve for x. And once we know the value of x, then we can find the measures of the angles. So taking the advice that we were given, all right, we know that 3x plus 7, we add that to 6x plus 11, and that is going to equal 90 degrees. Well, let's go ahead and combine like terms. Let's do 3x plus 6 equals 9x. And then let's go ahead and add 7 and 11. So we get 18. That equals 90 degrees. Let's go ahead and solve for x by subtracting 18. We're going to go ahead and get 72. Then when we divide by 9, we're going to get our answer. We should get our answer of 8. So that's what x equals. Now we have to determine the measure of each angle from there. So we know the measure of angle A is going to be 3x plus 7. We can go ahead and we can plug in 8 for that x, do a little bit of math, so we get 24 plus 7. When we do 24 plus 7, we end up getting 31. So that's the measure of angle A. Now, to find the measure of angle B, we could input our x value of 8 in for 6x plus 11, or another option is to do 90 minus 31, because we know the two angles are complementary to each other. Okay, so when we do that, we're going to get 59 degrees. So we know the measure of angle B is going to be 59 degrees. All right, so it's looking pretty good. Now, this might be the part of the video where your teacher is going to have you stop and they're going to assign you your homework. So go ahead, pause the video, figure out what your teacher's assigning for your homework. And Miss Graham's class is going to look at the next page for our homework assignment. For our class, our homework is going to be page 48, and I want you to do numbers 8, 9, 10, and 11. So you're going to go ahead and do problems 8, 9, 10, and 11. So that's going to be homework for tonight. When you do finish those, go ahead and submit it to Schoology, making sure you show all your work on each of these.